This is a problem on how to determine the pH of an alkaline solution that contains potassium hydroxide dissolved in it. So here we have 0.028 grams of potassium hydroxide that is dissolved in 650 milliliters of the solution. In order to solve this problem, we have to make the assumption that sodium hydroxide is a strong electrolyte. The molarity of the electrolyte is the molarity of the hydroxide ion. That's a major assumption that we make in order to proceed with the calculation. If this statement is true, the first thing to do is determine the concentration or molarity of the solution. For doing that, you can use the following equations and substitute the numbers. Concentration can be determined by dividing the number of moles over volume in liters, and moles are calculated by dividing the mass of the solute over molar mass, and you can cancel the grams, you get the unit of moles, and substituting or combining the two equations, C is equals to molarity is equals to m grams divided by molar mass is grams times mole divided by volume in liters. And if you substitute the numbers in this case, it would be equal to 0.028 grams divided by 56.11 gram times mole, 56.11 gram being the molar mass of potassium hydroxide divided by volume in liters, which is going to be 0.650 liters, and that's equals to 7.68 into 10 to the power of -4 moles per liter, or m. M represents molarity is equals to moles liter raised per liter, or moles liter raised to -1. Potassium hydroxide dissociates as shown. So molarity of potassium hydroxide is equals to the number of moles of potassium, which is also equal to the number of moles of hydroxide ions, because potassium hydroxide is a strong electrolyte. So if you have the molar concentration of potassium hydroxide, OH minus, that's going to be 7.68 into 10 to the power of -4 moles per liter. We can calculate the KOH, which is equals to negative log OH minus ions, and that's going to be equal to negative log 7.68 into 10 to the -4, which is equal to POH is equals to 3.11. We know that pH plus POH is equals to 14, or pH is equals to 14 minus POH. Since we calculated POH, that would be equal to 14 minus 3.11, or the pH is equals to 10.89. And as we already know, basic solutions have a pH greater than 10, and therefore our calculation represents a higher value for the pH, which is obviously correct in this case.